Hi, this is Ms. Fitzmars. This video is an explanation of free response number 10 in your break review packet. So in this problem, we have a physical setup, which is basically two masses attached to a pulley, one sitting on a table. It tells us that the table is frictionless, and basically what's happening is the students are putting weights from one tray into another, and in each trial they put the number of masses in tray A, the number of masses in tray B, and they time a 2-second interval, and in that time, after that time, they basically mark where A has traveled to. Okay, so they're kind of like collecting this X that A has traveled to. In part A, it says students are asked to use the data to calculate acceleration due to gravity in the room. And we're asked to figure out what should they make their y-axis and what should they make their x-axis. So we need to figure out some equation related to this experiment, related to the data that we're taking, which is x. We also know t. We can probably get like MA and MB and somehow relate that to gravity. So that should make you think about kinematics, because we have a distance and we have a time. Okay, now because we have distance and time, you should think about the first kinematics equation. So we have x equals x naught plus VOT plus 1/2 AT squared. We know that XO and VO are 0. We know that t is 2 seconds, so we can plug in 2 squared. And we have x is equal to 1/2 times a times 2 squared, or x is equal to 2a. And we need to find some way to relate a to g, the acceleration due to gravity, and these masses. So that should tell you, okay, I should be thinking of the forces acting on my system, and maybe making a system force body diagram. So I'm going to go ahead and do that. I have a system, I'm making my force body diagram, and I have Fn, I have mg, I'll say mag, and then once I unwrap this pulley, so I'm sort of unwrapping it this way so that it stands straight out, I have mbg pointing to the right. Okay, I can write out my Newton's second law, so I have sigma f, the forces acting on my system are equal to the mass of my system times its acceleration, and it's accelerating in this direction, so I only care about my x forces, and that would be mb times g is equal to ma plus mb, like my total mass, times acceleration. And I can solve for acceleration, or I can put x over 2 in for acceleration. It doesn't matter which I do, but I need one equation that relates g to my masses. Okay, so I'm actually going to solve here for acceleration in this equation. So I have acceleration is equal to x over 2, and I'm going to put that in right here. So I have mbg equals ma plus mb times x over 2. Now I have what looks like a linear equation that relates things that I've measured and g. I want to solve for one of them, and I want g to stay in my numerator, so I'm actually going to solve for x. So I can divide both sides by ma times mb over 2, and I get x is equal to 2g times mb over ma plus mb. Now, looking at what I have and the options they give me, I know x is a variable. It's like my resulting variable. I know that mb also varies, but ma plus mb is a constant, and so everything inside of what I'm circling right now is a constant. Okay, so mb is varying, ma plus mb, my total mass, because I'm just moving my blocks from one place to another, is constant, 2 is a constant, and g is a constant. So what I'm going to do is I'm going to make x my y-axis, and I'm going to make mb my x-axis. Now everything inside of here will be my slope. Alright, in part B it asks us to explain how you would use the slope of the graph to solve for g. Okay, so basically, since we have x is equal to 2g over ma plus mb times mb, our slope is equal to 2g over m total. Okay, and I can solve for g. I multiply both sides by m total, so I have m total times slope, and I want to get rid of the 2 as well, so I divide both sides by 2, and that's equal to gravity. Okay, then once I've found the slope, I can plug the numbers in and solve for g. Okay, finally in part C, students notice that there's some error in their data because they don't get a straight line. Which of the following graphs indicate that friction would be the primary source of the error? Okay, so to think about this, and I'm going to draw a line, this is part B, and we're doing part C. To think about this, we need to go back to our force buddy diagram, and instead of having just Fn, MAG, MBG, and nothing else, we have to add in friction. And we know that friction is equal to mu Fn, and in this case, friction would be equal to mu times MAG. Basically, the bigger MA is, the bigger friction is. And we can look at our equation, okay, and so we get sigma F is equal to MA still. And now we have MBG minus mu MAG is equal to MA plus MB times a, or times x over 2. Okay, because remember we solved for x over 2 is equal to a. I'm still using that, that's still valid. And if it helps you see this more clearly, we can solve for x. So we end up with x is equal to now mb g minus mu ma g over still our m total and times 2. Okay, so our question is, when does this equation look like our line? And the answer is, if MA is small, then x is about equal to 2mb g over m total, because we can basically cross out this part. But if mb is small, then we're really far off. Okay, so looking at these graphs, graph 1, and remembering that this axis is x and this axis is mb. This is x and mb, x and mb. We know it's close when mb is big. So looking at these three graphs, this one is close when mb is big, and we know that it's far off when mb is small. So graph 1 is the correct graph. Alright, in terms of points, in part A, there is 1 point for making x should be the vertical axis. Okay, there's 1 point for making MB your horizontal axis. There's 1 point for indicating that you need to use the first kinematics equation, so using x equals x naught plus VOT plus 1/2 AT squared, since, and you have to include these, we know x and t, and there's 1 point for indicating that we should use Newton's second law to find acceleration. In part B, there's only 1 point. You need to indicate that g is equal to your slope times m total divided by 2. And then in part C, there's 1 point for selecting graph 1. And then there's 1 point for explaining that FF is proportional to the mass in tray A. So when MB is small, MA dominates, and the line is far off. But when MA is small, MB is large, and the graph is close to what we expect.